Right, I'm just cleaning up a set of V-blocks because I need to check this crankshaft for trueness, see if it's square to itself or not. And to make sure this is accurate, I'm just putting them against a square so they're exactly parallel. And all we do is we want to put the V-blocks on here. Now that crankshaft is fairly clean. It doesn't look the cleanest, but it is actually clean. And we'll just slot that in there like that. Sliding it up to the V-block so it's tight and all locked in. And then we need a dial gauge. This one is in 5/10,000ths of an inch. Now the important thing with using a dial gauge is that it is exactly 90 degrees to the surface you're trying to measure, because if it's not going to work. You'll get all sorts of things. Admittedly, we are only testing for out of true, so we're not actually taking a measurement, so it doesn't matter. We're not going to get cosine error or any of that stuff, but we do want it to be a fair test, so we just set this up square so that it is measuring down the middle. Now I've got those V-blocks exactly parallel on a square. I've got the magnetic base on the V-block. So we've got this set up and it's exactly vertical that way and exactly vertical that way. So it's pointing exactly down to the ground. And all we do, we put it in the V-block so it can't wobble about, and we rotate it. And that is actually, and I'm measuring right on the shoulder of the taper, and it is out a little bit, look, but not majorly. This is 5/10,000ths of an inch measurements, so it is 1/10,000th of an inch out, which isn't bad for a two-stroke crank. Because I've got to strip this crank down. If we actually look at the crankshaft, take that out of there. We look at the bearings on there. This bearing is nice and silver and rotates freely. This bearing is very notchy and purple, like it's got hot. And take a good look at those. See, it's got hot somehow. So I think we're going to be taking those bearings off, changing them. Whilst I'm doing that, I might as well change this big end bearing and this little end bearing in there, because we're going to change the piston and rod, because it is seized, or it has seized. And if we look at that, we can see where it's nipped up. There we are, that is seized up. So this engine was well and truly knackered. Now I just wanted to know what the starting point of this crankshaft was. Was it running true when it was originally in the engine or not? Which it seems to be. So I'll just, you know, we'll strip it down, we'll press it apart, and then I'll show you how to reassemble a crankshaft when it's been pulled apart. And all you need is a set of V-blocks, a dial gauge, or a wiggle bar. You can do it with a wiggle bar if you've got a long enough one. It needs to be very long, but a dial gauge is best. And a brass or copper hammer. I prefer a copper hammer, it dents less. And then I'll show you how to disassemble this and then press it back together and make it true again. Right, so we've got this crankshaft set up now on its bearings in the V-block, and I'll just show you where the high spot is. Just there. So that is pretty much where the crankshaft pin is. So that means that the bottom of the crank needs squeezing together just between the V-blocks, a tiny little squeeze, and that would bring that down. But we're not going to worry about that now, because we're going to strip this crankshaft apart in the next video. I'll show you how to press it apart successfully, change all the bearings, machine that end. We're going to get it square, and then put a new thread on the end. But I had to check before I started that the crankshaft wasn't bent majorly out of shape or misshapen or anything like that, so that when I put it in the chuck and I put it in true, I know that that hole there is exactly parallel with this shaft, and that the shaft wasn't bent. I mean, the engine wasn't ever run in my presence, so I don't know how it was performing, if it was vibrating or anything. So we've got to do these checks before we start. So we know this crankshaft is straight and true to within 0.010 of an inch. Yeah, we'll take it apart next video and show you how to put it all back together again and true it up. The other thing I want to check whilst we're here is the free plate there. So we'll push this all the way over to the left, and we'll stick a feeler gauge in here, just like that. And I've worked my way up through the feeler gauges, and this is just right. And that is 0.4 of a millimetre. I went through my metric and imperial ones, and that's the one with the nicest fit. So I know that gap there is 0.4 of a millimetre, and those are engineered surfaces on that end. So I shall write that down, and when I press it back together, I know that once I've reached that point, it's in exactly the same position as it is now. So there you go. Right, we'll start disassembling this crankshaft. We'll take the pin out the other end first, if I can get it out. Bugger. Went. We'll just flip this over and gently tap this out of here. We're going to get a new gudgeon pin anyway, so I'm not too overly worried. But as there wasn't very much material in there, there you are, out that comes, and there's the bearing. So that's the piston off, and as we can see, when we take it out, that's got hot, look, very hot. It's gone blue, and the piston itself is seized, so they're all scrap really. Chuck that in the bin. Right, next it's the bearings turn. So we'll knock these bearings off. Quite easy to do. Put it in the vise like so, and hit it with a hammer. Right, so I've got this in the press, and we're just going to try and squeeze it out now, see if it wants to come out. Oh, there it goes. Okay, so we're back in the workshop now, and this is, the crankshaft was like this. We've pressed it apart, and this is the bottom half, which we don't really want to mess around with. It goes that way around. We'll just pop that in the box. We'll have a look at that later. And this is the bit we've got to repair. So now we're going to have to put this in the lathe, zero it in, and machine off this end. So let's head over to the lathe. Now I've mounted this in the lathe. I've just put the tapered end in the taper of the tailstock and shimmed it up so it sits square, and as far as I can tell, rotating it, it seems fairly central. There's no big errors at this end and no big errors at this end, so I'll clamp this down and then we'll return. Okay, so this is all held in the lathe now. I had to shim it up on this end by 30 thou, that is, and that is exactly 3 mil. So with them measurements I managed to square it up. Okay, so let's make some chips then and see what happens. Very slowly. I'm taking like a couple of thou at a time, and I'm using a HSS bit because it's more forgiving than carbide. Sorry, I'm trying to hold this because I couldn't get a good light angle. It's not the easiest thing to machine. It's all out of balance. I'm going as slow as I dare, and I'm using a high-speed steel bit. Simply because A, I can resharpen it, and B, it's more forgiving with the cut. It'll stand being jammed in. It's not going to grip and do all sorts of things like carbide does. I haven't got it spinning fast enough for carbide really. Okay, and advance another thou or two, and again. We're just taking such tiny cuts off this because the whole thing's out of balance and not the best supported, and I haven't got a fixed steady that I can put in there. We'll just run it like this, and I'll keep shaving this back and then I'll show you later. Okay, so I'm on my last pass now, and this should clean up the face enough for me to put a 10mm hole down the centre for about 5mm, and then weld the stud on, and then we can thread that. I daren't go any faster than this, it makes the lathe wobble about even though it's bolted to the floor. So just incrementally go forward as slow as I can, and I'll show you when it's done. And that's the end of the crankshaft, all faced off, and now we've got to centre drill it and then drill a hole for the 10mm stud, which I'll drill undersize. I'll drill about 5-6mm, maybe 7mm, and then I'll machine down a piece to fit it exactly, and then we'll weld that on. Now it's time to drill the end, so I want to centre drill it first, and to ensure accuracy I'm using the smallest centre drill I've got in a collet chuck. This is the most accurate way. I've got a hold in it really, and the collet holds it tighter than the 3-jaw Jacobs, which I'm not convinced is 100% accurate, so we'll give it a go and see what happens. Okay, here we go. There we are, it's making chips now, and they're not McCain's, so it must be good. There we are. We're nearly there. There we have it, centre drilled. And that's the centre of the crank drilled, ready to receive a larger hole to mount the stud on, and then we'll weld that on. I might do that mounted to the lathe just for concentricity and ease of welding. I'll have to disconnect the electrics, but I don't see why it should be a problem. And then we'll drill this out to a bigger size and then make a stud to go in it. So I'll remove the whole faceplate and put the 3-jaw on and machine the stud to fit this, and then put the faceplate on, and so on and so forth. Now normally when I would drill something like this, I would advocate using a very small short drill bit, but I can't do that because I haven't got one the right size. So I'm going to drill this out slowly. It seems to be doing its thing, not wandering, so we'll just get that drill embedded in there, and once it's in, it's going to hold its own. Then it will guide itself to an extent. So I just want a deep-seated pocket for this stud to go into. So I've got a decent hole in it now, and we'll make a stud to go in there, and then we can weld that on, sort out the weld, and then thread it properly. Right, now that that's bored, we'll take this off of here. I've already loosened it, and we'll put 3-jaw on and make a stud to go in this hole that's the diameter of that hole, and then about 11mm on the outer edge, so I can weld it and then machine it down. Now normally when I would drill something like this, I would advocate using a very small short drill bit, but I can't do that because I haven't got one the right size. So I'm going to drill this out slowly and see what happens. It's not wandering, so we'll just get that drill embedded in there, and once it's in, it's going to hold its own. Then it will guide itself to an extent. Seems like a good locating pocket. Let's have a quick look at it. Pull the tailstock out the way. Sorry, I'm having to hold this by hand because my camera gantry is not exactly brilliant at the moment. There we go. So I've got a decent hole in it now, and we'll make a stud to go in there, and then we can weld that on, sort out the weld, and then thread it properly. Right, now that that's bored, we'll take this off of here. I've already loosened it, and we'll put 3-jaw on and make a stud to go in this hole that's the diameter of that hole, and then about 11mm on the outer edge, so I can weld it and then machine it down. Okay, so we're now going to machine the little nubbin for the end of the crank to put the thread on, and a little locating dowel about 5mm long, so we'll do that now. Right, so this is the piece of steel I'm going to use for making the threaded end, so we'll just mark it up. See that now, and we'll just move in and take that bit down to about 7.5mm. Okay, well, that seems fairly close. So we'll just try fitting the stub into it now. I don't see how close it could be, but there we go, it doesn't quite fit, so we'll try again. Do it again. There we are, perfect fit there. So we'll take that off now. Let's see what this comes out as. .3, 10.37. When I cut the thread, I want to file the tops of the thread off just to smooth them out a little bit, and that 0.3 of a millimeter will disappear with the file, so we'll do that, and then we'll have nice smooth threads then. Right, so I've got the little nubbin in the end of the hole that we drilled, and I've held it down with a puller just to hold it in place whilst I weld it in. So I'll go and get the welder, weld this in quick, and we'll put it back in the lathe and true it up. Right, so I've got the compound set using a dial test indicator. Got to clean up the weld. It wasn't the most successful bit of welding I've ever done. So I've used the indicator to set the compound so that when I turn the compound in and out, the dial doesn't move as it travels along this taper. So I know that the compound angle there is exactly the same as this, and I completely ignore the scale here. I don't even look at that because that's about as accurate as a fart in a box. So we don't bother with that. We always set everything by a dial if we can. So I'll clean this up and we'll see what it looks like. We just do it on the compound. Sorry about the vibrating, but the thing's out of balance because it's a great big crankshaft. very slowly on the compound. Take it back. This will take quite a while. Look at that. And it is doing it. It's getting there. Got a little bit more to go yet, but we're getting there. I'm really sorry about the quality of the video. This thing's out of balance being a crankshaft. So I'm just videoing what I can. Now we've just cleaned this weld up completely. And we're just taking the final pass to get it down to size. There we are. I think that'll be close enough. So that's the crankshaft repaired now. We've just got to cut a thread in this and we'll be done. So that's a 10B 1.5 thread, I think. So yeah, we'll get that cut and then it'll be done. Right, so I'm going to thread this now and I've got it butted up. I've started it going. I've got about 2 turns on it. So this is quite a long cut. And I've got it the wrong way round as well, so the chamfer is actually on this side of the I started it, turned it round, so I'm now going to cut the thread very slowly. I can't really back it off with one hand, so I'm just going to have to go slowly and see what I can do. It's quite a tight thread. It's definitely doing something. Let me just nip that up a bit more. And I've got it butted up here so it's actually holding itself. It's doing quite a good job. And it is cutting the thread slowly. And you can see how with this pushed up against it, it does help hold it still. Right, I think we're nearly there. I can see the lip coming up. There we go. There it's disappearing, look. It's working. There we go. So I've got a thread on the back of that. Now I can back this out. And I think, yeah, we've got a thread there, so that's cool. So I'll just keep going until it stops up against that shoulder. Now I've got this in frac to bunt, or back to front, whichever way you want to call it. Because I wanted to, right, we'll back this out now then. There we go. It's working, it's done its job. So there we go. Right, I'll just put the phone down and take this off because I don't want it to drop. And there we have it, one repaired thread. Right, so the proof of the pudding is, does the nut go on? No play in that. And there we go. One crankshaft saved. So next time we'll reassemble the crankshaft, balance it, true it up, and start assembling the engine. There we go, job's done.